This is a neutron star. When a massive star explodes, not all the material is ejected into space. Some of it collapses into an extremely compact object known as a neutron star, inside which gravitational forces crush protons and electrons together, turning them into particles known as neutrons. What is a neutron star made of? How dangerous are neutron stars? What will happen if a neutron star arrived in our galaxy? My name is Jarman Singh Gill, and you're watching Nature&Science. A neutron star contains a few solar masses of material squeezed into a radius of only 20 kilometers. This means the matter is so compressed that a thimble full of it would weigh millions of tons on Earth. Neutron stars are the strongest known magnets. Like many objects in space, including Earth, neutron stars have a magnetic field. While all known neutron stars have magnetic fields billions and trillions of times stronger than Earth's, a type of neutron star known as a magnetar can have a magnetic field another 1,000 times stronger. These intense magnetic forces can cause starquakes on the surface of a magnetar, rupturing the star's crust and producing brilliant flashes of gamma rays so powerful that they have been known to travel thousands of light years across our Milky Way galaxy, causing measurable changes to Earth's upper atmosphere. The intense gravity of neutron stars requires scientists to use the general theory of relativity to describe the physical properties of neutron stars. Measurements of neutron stars give us some of the most precise tests of general relativity that we currently have. What is a neutron star made of? Most of the basic models for these objects imply that neutron stars are composed almost entirely of neutrons, subatomic particles with no net electrical charge and with a slightly larger mass than protons. The electrons and protons present in normal matter combine to produce neutrons at the conditions in a neutron star. A neutron star is a giant nucleus. Fast-spinning neutron stars, whose radio emissions seem to pulse on and off, are called pulsars. Beyond the mass limit of a neutron star, about 3 solar masses, gravity becomes overwhelming and collapses the star even further, creating a black hole. All types of compact objects are significant sources of high-energy emission because of the enormous gravitational fields they tend to generate. Gravitational fields can accelerate particles in the vicinity to extreme velocities, which then emit gamma rays and X-rays. In just the first few seconds after a star begins its transformation into a neutron star, spinning neutron the energy rotates about 700 times the total amount of light emitted by all of the stars in the observable stars either currently or at one point have been pulsars, stars that spit out beams of radio waves as they rapidly spin. If a pulsar is pointed toward our planet, we see these beams sweep across Earth like light from a lighthouse. Neutron stars' pulses were originally thought to be possible alien signals. Beep beep beep. The discovery of pulsars began with a mystery in 1967 when astronomers picked up very regular radio flashes but couldn't figure out what was causing them. The early researchers toyed briefly with the idea that it could be a signal from an alien civilization, an explanation that was discarded but lingered in their nickname for the original object, LGM-1. A nod to the Little Green Men. It was later renamed PSRB 1919+21. Of course, now scientists understand that pulsars are spinning neutron stars sending out light across a broad range of wavelengths that we detect as very regular pulses, but the first detections threw observers for a loop. So, how dangerous are neutron stars? Neutron stars can be dangerous because of their strong fields. If a neutron star entered our solar system, it could cause chaos, throwing off the orbits of the planets and, if it got close enough, even raising tides that would rip the planet apart. But you don't have to worry yet, because the closest known neutron star is about 500 light-years away. And considering Proxima Centauri, the closest star to Earth at a little over 4 light-years away, has no bearing on our planet, it's unlikely we'll feel these catastrophic effects anytime soon. Probably even more dangerous would be radiation from a neutron star's magnetic field. There are many things we don't know about neutron stars, including just how many of them are out there, Horowitz says. We know of about 2,000 neutron stars in our own galaxy, but we expect there to be billions more. So most neutron stars, even in our own galaxy, are completely unknown. Just like magnetars, they are neutron stars with magnetic fields 1,000 times stronger than the extremely strong fields of normal pulsars. Sudden rearrangements of these fields can produce flares somewhat like solar flares but much more powerful. What would happen if one of the magnetars arrived in our solar system? Well, that's the topic for another Nature and Science video. Well, that's all for today. If you like our video, make sure you hit the subscribe button. I'm Jarman Singh Gill, over and out.